morning everyone, hope you all safe with a good health. With you Ms. Dina Al-Badri, science teacher for grade 5. Today we will start lesson 4, what are the Newton's law? In this lesson we will explain the laws of motion, describe inertia, relate motion in space to the lack of gravity in orbit around the Earth. So this lesson and the previous lesson is talking about a part in science called physics. In physics, the most important definitions, the forces, motion, Newton's law. Okay, we have new word, we call it inertia. Today we will know the meaning of inertia, the meaning of the first Newton's law and second law. Please listen and concentrate. Newton's first law. In the 1600, Newton published a book about how objects move in the physical world. So, the first scientist was talking about the first Newton's law in general. Scientist called Newton, Isaac Newton. He talked about the motion of the object in the world. Newton's make a summarize for his idea in 3 laws. We called them Newton's law. We called them Newton's first law, Newton's second law, Newton's third law. What is the meaning or the description of the Newton first law? Newton's first law described what? Newton's first law describes the motion states that no acceleration or change in motion can happen without an unbalanced force or push or pull on an object. There is no acceleration. What the meaning of the word acceleration? Change in the speed of the body. There is no change in the speed of the body without change in the motion. Okay? Without acting with a force on an object. In other words, objects at rest don't move unless unbalanced force acts on them. If the body doesn't act with a force, there is no motion. Objects in motion don't slow down, speed up, stop, or turn unless a force makes them do. Did you see here? When the car starts to stop, what will happen? You make a resist change in motion to prevent yourself to go outside the car like this man. Did you see? So, in Newton's first law, describes something called inertia, or the tendency of the object to resist the change in the motion. The meaning of the word inertia, it means that we move in an opposite direction. When the body moves in direction, the inertia, it means the opposite direction. So the car stop here. So the body make a sudden movement to resist this motion. Okay, so the inertia is the tendency of the object to resist the change in the motion. For example, when a car makes a sudden turn, your body pulls to the other side of the car.
Did you know that physics is about how things move and why things move? It was Isaac Newton who discovered the 3 laws of motion. He was a scientist who lived from 1642 to 1727. Let's first learn about the first law of motion. It is also called the law of inertia. It states objects will remain at rest or in uniform motion in a straight line unless acted upon by an external unbalanced force. To understand Newton's first law completely, we need to learn about inertia first. See, this is a very large sofa. What's special about it? It's stable. It is not moving. Now go ahead and try to move it. Oh, you can't. It's not willing to move. You can't move it as it is very large. Now try to move this small stone. Good. You can move it a little bit, but you had to put in a lot of effort. It was also like it didn't want to move from its original position. Even the smaller things don't want to change their positions. They don't want to move. Even a small stone takes some effort to move. This is the first rule of physics. Things like to stay where they are. No object in this universe would start moving unless some external effort is put on it. It's like all things in the world are lazy. Now the question is, if things are lazy and they don't want to move, then how does the movement happen? The answer is that there are so many things in the universe which push and pull other things and force them to shift their positions, like you force the small stone to move. But as we said earlier that things are lazy, they would try and stop their movement as soon as the effort was removed. Well, you'll be wrong if you think like that. You'd find it very strange to accept that when a small stone was still, it wanted to stay still. But once you'd put it in motion after putting some effort, it would like to keep on moving. In reality, it would keep on moving forever and ever. But somehow it stops. But it stops not because it wants to stop. It stops moving because things in its path force it to stop. It may be due to air, or if it bumps into a tree or rough surface on the ground. But suppose there were no tree in its way, or there was no roughness on the surface, and also imagine that it does not have poles or trees in its way. The stone would never stop. It would keep on moving. It happens in outer space, where there's no air or roughness. If you kick a small stone, it'd keep on moving and would never stop. So how can we say that things are lazy? See, the small stone wanted to move forever, but it was stopped by the resistance of air, trees, or roughness of surface. It's like you moving on a slippery road. You'd keep on moving unless there was some effort put in to stop you. The same is true with the small stone in outer space. It would keep moving, as nothing came in its way. It also doesn't want to stop, as it is too lazy to do that. So now we can change the first rule of physics. Things want to stay in the position they are, to things want to keep doing what they are already doing. If things are at rest, they want to stay at rest. And if things are moving, they want to keep moving. In other words, things are lazy. So there's a lot of laziness in the universe. Physicists have a special name for this laziness. It is known as inertia. So now you understand Newton's first law of motion. Can you write it? Well, you are very much right.
So in the Newton's first law we said that the body there is no acceleration if there is no force acted on the body. In the Newton's second law, Newton said that what the motion state and object acceleration depend on two factors: the amount of force applied to the object and its mass. So in the Newton's second law, he said that we have two factors affecting the force. Acceleration and the mass. So in the Newton's second law, he said that the acceleration of the body affected by two factors, mass and the force. According to this law, so the force equal mass by A. A is the acceleration of the body. What is the meaning of the acceleration? The change of the speed of the body, and the mass of the body, and the force acting on the body. The mass of an object affects how or if the object moves when a force is applied to it. Newton's second law explains why you must use more force to move an object with a greater mass. So يبقى in Newton's second law explain why you must use more force to move an object with a greater mass. So according to this law, when the mass is 2 kilograms, so I need more force. When the mass 8 kilograms or 10 kilograms, I need the same force. When the body with a mass 2 or more force. So according to this law, Newton said that we need more force to move a greater mass. We need more force to move a greater mass. Okay, so today we talked about the meaning of inertia, Newton's first law, Newton's second law. Next time, inshallah, we will talk about Newton's third law. Okay, The Newton's second law can be written by the shape, force equal mass by acceleration, or by the symbol. Both of them is correct. If you want to write them like this or like this, both of them is correct. Okay, that's all. Hope you all understand. Next time, inshallah, we will talk about Newton's third law. Please watch this video about Newton's first law, second law. Watch carefully and to understand this part. Thank you.
Now let's move on to Newton's second law. As we know from the first law that to overcome the inertia of an object, we have to apply unbalanced force. Newton's second law talks about how fast an object would move. Well, it states acceleration of an object depends on the mass of the object and the amount of force applied. In mathematical terms, Newton's second law states that force is the product of mass and acceleration. To cause an object to accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. Look at these two swings. If you apply the same force on both swings, check whose goes faster. Let's first push the little kid. See? It goes very high. Now push this fat man with the same force. See, it does not go far, because it has more mass than the little kid. So the more mass there is, the force required to push the object is also greater. Let's look at the mathematical formula of the second law again. It's the product of mass and acceleration. We've already learned that if there's more mass in an object, to move it, we need more force. Now let's see this kid sitting in the swing. If we apply little force, then it goes a small distance. Now if we apply a lot more force, it goes very high. So to get more acceleration, we need to apply higher force. So now you can understand the relation among force, mass, and acceleration.